Right, so we're asked to find the equation of the tangent to the curve with parametric equations of these here at the point where the parameter t is equal to 2. So you've just got to think back to the work we learned from last year. How do we find the equation of a tangent to the curve? Well, if you remember, we need the gradient at the particular point. So in this case, when t is equal to 2, we also need a point, don't we, on that line. So we need the point where t is equal to 2. Okay, but to get the gradient, of course, we need to find dy dx. So we'll go about the approach that we've been using so far. So we'll differentiate this and we'll differentiate that. So we'll differentiate this in terms of t. So dx, this is in terms of t, it'll be dx by dt. Well, 9 minus 9t squared, 9 disappears. Minus t squared becomes minus 2t. Same here, then we'll differentiate this, dy by dt. T squared becomes 2t. 6t becomes 6. Okay, and then of course don't forget to flip this. So dt dx will become minus 1 over 2t. Okay, remember to get the gradient, we need dy dx, not forgetting that, right? So we've got to use the chain rule now, dy dx. So dy is on top, dt on the bottom, dx is on bottom, so dt dx. So we've got dy dt, which is 2t plus 6, times then dt dx, which is 1 over, or minus 1 over 2t. So we can straight away put the 2t there, and we'll put the minus in front. Okay, so we can work out dy dx because we have the parameter given to us at the point P to be 2. So we simply say then, look, when t is equal to 2, dy dx is equal to minus 2, so we sub it in, sub the value of t equals 2 in to the gradient function, and you can use a calculator. So we have minus fraction 2 times 2, which is 4, isn't it? And then on the bottom then 2 times 2 again. So we get minus 5 upon 2. So this is the gradient when t is equal to 2. But remember, as well as having the gradient, I need to know the x and y value. And I do that by subbing in t equals 2 into these up here, right? So again, when t is equal to 2, x will equal to 9 minus 2 squared, which is equal to 5. And y will equal to 2 squared plus 6 times 2, which of course then will equal to 16. Okay, so it goes through the point 5, 16, this tangent does. So I've got my point of 5, 16, and I've got my m value, the gradient, to be minus 5 over 2. So the equation of the tangent remember the equation formula, y minus y1 is mx minus x1. So y minus 16, okay, that's your y value, minus 5 over 2, your gradient, x then minus the x value, which is 5. And then we've got our equation, essentially the tangent. To tidy this up then, we can take that 2 up here and multiply. Okay, let's expand that bracket out then. So we'll have what, 2y minus 32, 2 times y, 2 times minus 16 is equal to then minus 5x plus 25. And then if I get everything over maybe to one side, I'll have 5x plus 2y minus 57 equals to 0.